So hello guys, we are back with another video. Today we are discussing about how we can convert the decimal to binary. In the previous video we have seen how we can convert the binary to decimal. In this video we will be seeing how we can convert decimal to binary. Suppose if we are given a decimal number and we have to convert it to binary number, how we can convert it. So many of you might be familiar if you have studied the computer architecture or digital electronics subject. In that we have seen that how we can convert the decimal to binary. For those who don't know, so let me explain to them. So for example, if you have a decimal number 16, how we can convert this? We can will divide this number by 2 and store the remainder of this in some array or some variable. Okay, usually in some array. Okay, now and then we will again divide whatever will be the coefficient after dividing the number 16 by 2. Whatever will be the coefficient, again we will divide it by 2 until the number is not 0. Okay, so whatever will the remainder is again 0, we will again store it in the array. Okay, now we have 4. I will again divide it by 2. Now what will the remainder is 0. Now again the quotient is 2. Now what will divide it by 2. Now what will be the remainder? The remainder is again 0. Now what is the quotient? The quotient is 1. Now we will divide it by 2, and what will be the remainder? Remainder is 1. So here we will stop, because after this the quotient will be 0 and the remainder will be, and so we have to stop over here. Okay, now as we know that I know that the decimal binary expansion of 16 is 140. So now we have to write this in the from bottom to up way. So this will be written as 1 followed by 40. Okay, so this is how we can convert a decimal number into a binary number. Let me give another example to you. So suppose if we are given a number 4. So I know that its decimal binary expansion is 100. Okay, so let us see how we can do this with the above logic that I have explained it to you. So we will divide it by 2 and store the remainder in this. Okay, now we will again divide this the quotient of the above operation with 2 and store the remainder. Now I will again divide the quotient, that is 1, by 2 and store the remainder. Now I will not do further because the quotient is now 0, and now I will write the output as from bottom to up, that is 100. So this is how we get our this is how we get decimal to binary. Now we have to code it. So how we can code it is, first of all we have to use the same logic. So first of all what we will do, we will create a array, that is binary, and if we require 32 bits, if we have 32-bit processor, we can create an array of 32 bits. If we have a 64-bit processor, then we can write 64. It is your choice what you want to write. So I am writing 32. So I have created an array. This is an array of size 32. Okay, now what I will do, what I have said that until my number is not equal to 0, I will keep on dividing the number by 2 and store its remainder in the array. So what I will do, while n is greater than 0 or n is not equal to 0, whatever condition you want to write, you can write n is not equal to 0 or n is greater than 0. What I will do, I have also create a variable, that is int I, and initialize it to 0. Okay, now what I will do, I have to store it in first position. So I will store it in binary of I equal to what I have to divide and store the remainder. This is my number and I have divided modulus this, I have divided, and whatever be the remainder I have stored in the array of at position 0. Okay, now after that what I have to do, I will continue dividing the number by 2 until my number is not equal to 0 or my number is greater than 0, until the number is greater than 0. Okay, now what I will do, I plus plus. Okay, now as I told you that our number is in the reverse fashion, that is here what you have seen that our number is 00001. Now we have to reverse this number, so I will run the loop from j is equal to I minus 1, I greater than equal to 0, I am j minus minus, sorry, this is not I, this is j, and j minus minus. What I will do, I will print binary of I. Okay, now let's call this function, that is binary function. It's is it binary? No, this is dec to binary, decimal to binary, and followed by n. So let's see if it is giving us the right output or not. So we have to enter the decimal number. Suppose I have entered 16. No, there is some mistake, I think. Sorry. Here I have written n is greater than 0, binary of I equal to, yeah, it is correct. Now I plus plus, this is correct. J is equal to I minus 1, j greater than equal to 0, j minus minus. Yes, oh sorry, this is not I, this is j, sorry. Now let us rerun this program. Now enter the 16. Yeah, we are getting the right output. Again, we will rerun the program. Let's see for another test case 8. Yeah, we are getting the correct output 1000. This is a binary expansion of 8. Let's see for 10. Yes, we are getting correct output. This is how we can convert our decimal to binary number. I will again explain it to you. First of all, we will create a binary array. Now we will initialize one variable to set it as 0. Now we will check until the number is greater than 0. We will store the remainder, divide it by 2 and store its remainder in the array. And what we will do, we will keep on dividing the number by 2 until the number is greater than 0 or the number is not equal to 0. Increment the I. Now as we know that the number which we get as our output is in the reverse order, not in the desired order which we want to get. So we will iterate through the array from last to first, and then we will get our desired result. Okay, so I hope you understood this concept. That is how we can convert the decimal to binary number. If you like the video and find it useful, please don't forget to like, subscribe and share this video with your friends. Thank you.